page 408, we're going to do some reviewing for topic 7. So lesson 7.1 was on understanding the Pythagorean theorem. Pythagorean theorem again says that a squared plus b squared equals c squared, and that's for a right triangle where a and b are the legs of the triangle and c is the hypotenuse, which is the longest side. Okay, once again, we've talked about the hypotenuse is always across from the right angle, and if you want to make that right angle into an arrow that points towards the hypotenuse, you can do that. So for number 1, they want us to find the length of the hypotenuse. So I'm going to start with my formula, and then I'm going to think about if I've already been given the hypotenuse or if I need to find it. So on this problem, across from the right angle, we don't know what that length is. So it looks like for this problem we're trying to find the hypotenuse. So 5 and 12 are the legs that we'll put in place of a and b. Make sure you remember to square both of those. So 5 squared is 25, 12 squared is 144. If you add those together is 169. And then you can take the square root. We can do plus or minus, even though we know the negative answer is not going to work. And then if you work that out, square root of 169 is 13. Once again, we can't have a negative answer. So 13 centimeters would be our hypotenuse. Once you get that answer, you make sure that since it was the hypotenuse, it should be the longest side. So make sure that it's longer than either of the other two sides. And we actually would know on this problem actually that it said find the length of the hypotenuse. That would be another clue, a good clue that we're finding the hypotenuse on this one. Number 2, they want us to find the unknown side length to the nearest tenth. So same thing, let's look at about the hypotenuse. It looks like 9 is our hypotenuse on this one. So 7 is one of the missing sides, and the other one, or 7 is one of the known sides, and the missing side is one of the legs of this triangle. So the 7 could go in place of the a or b here. So 7 squared is 49, 9 squared is 81, and then we can subtract the 32, and then if we take the square root, and they said go to the nearest tenth, so that would be about 5.7 inches. Okay, so 5.7 inches, that's smaller than the hypotenuse, and it's kind of in line with our other numbers, so that should be good. Section 2 was the converse of the Pythagorean theorem. Basically, it just says Pythagorean theorem only works if you have a right triangle. So if you put your numbers in for A, B, and C, and if it works, then we know we have a right triangle. If it doesn't work, then you don't have a right triangle. So for number 1, to see if that's a right triangle, start with your Pythagorean theorem formula. This one, here's our right angle. So 37 would be the hypotenuse. And technically we're checking to see if this works. 12 squared is 144. 35 squared is 1,225. 37 squared is 1,369. And if you add those together, they are equal. So we could say yes, meaning yes, it is a right triangle. Number 2, same idea. Looking at the numbers, 3 is the biggest one, so even though they didn't draw a picture, we know that that's going to be the longest side on this triangle. So 3 we'll put in place of C. Two squared is 4, 3 squared is 9, 1.5 squared would be 2.25. And those are not going to be equal to each other, so we would say no, that is not a right triangle. Number 3, similar idea. Once again, look at your numbers. Make sure you recognize the hypotenuse as the longest side, which would be 41. So 9 squared is 81. 40 squared is 1,600. And 41 squared is 1,681. So that works. So that is a right triangle. Section 3, we went to a little more challenging Pythagorean theorem problems. Number 1 is not one of those more challenging problems. This is more like what we just did in the last section. So, we could draw a picture here. And trying to find the diagonal would be our hypotenuse. Okay, so that's really like the ones we've just been working out. Okay, so without working that out all the way, that should come out to be about 106.5 feet. Number 2 is a little more challenging. It's still not quite as challenging as we could get in this section, but they have a packaging rod is 7.5 inches along the diagonal of the base. The height of the box is 18 inches. What is the length of the diagonal? Oh, and actually really this isn't any more challenging than any other problem we've been looking at. So we're trying to find the hypotenuse here. Once again. Okay, so if you work this out, you should end up with 380.25, and then you can do square root of that. And that would be about 19.5 inches. Okay, so really nothing more challenging than anything else that we've done on this problem. So I would recommend looking back at your assignment for this section, going back and redoing some of those problems, cover up what you did and what the answer was, and work those out, or otherwise go on the Savas Realize website and try to look for more challenging problems on there. This would be a more realistic problem of what we could expect to see from section 3. So we'll actually have to find 2 missing lengths here. Another thing they could do without even drawing out C or D, they could just say what would be the longest diagonal in this rectangular prism, and then we'd have to just know that that's what we got to figure out. So the first thing we would have to do on a problem like this, we would have to figure out what C is equal to. So for C, if you can imagine, the bottom of the rectangular prism looks like this. And here's C. So if you can just imagine this rectangle here, that's what we're going to be working with. So hypotenuse is what we'd be finding for that one. So 4 squared is 16, 10 squared is 100. Add those as 116. And then you can take the square root. It's a good idea at this point just to try the square root of 116 just in case it comes out evenly. It doesn't. The other thing about it though is we know that was the hypotenuse. It has to be the longest side in that triangle. So that's about 10.8. I just want to verify that that's bigger than either of the other legs. So the biggest leg that there is in that triangle is 10. We've got 10.8, so we should be in good shape for that part of it. Then once we've got that, we can look at figuring out what D is equal to. So we just found out C was square root of 116. We're trying to find the diagonal. So our other dimension of this triangle would be 3. And once again, we're trying to find the diagonal. I did D for diagonal, or maybe we would have been given that letter. This is similar to one that we did in your book for your assignment. I just did that because we already had a C, just so we don't get confused on what's what. So 3 squared is 9. Square root of 116 squared is 116. Those just cancel each other out. And I just made these problems up, so we'll see how this comes out. But so we add those together is 125. And then let's say we're just going to the nearest tenth here. So that would be about 11.2. And I didn't put units on this. You know, you could say maybe this was feet or something. I should have put that on the problem and I forgot. So anyway, this is more of a challenge question that we could get from section 3 though. Section 4 was finding distance between points on a coordinate plane. So if we want to find the distance between C and D, one thing to watch for, make sure if they're going by ones or not. On this one, it looks like they are going by ones, so draw a straight line between those, and then we can create a right triangle here, and then count how many squares you've got in between those points. And then it's just like what we were doing before. And it said nearest tenth. And so that would be, it's about 6.7. And then it says in the question, it says each unit on the grid is equal to 25 miles. So So if one unit is 25 miles, we've got about 6.7 units. So you could do 25 times 6.7, or a little more accurate would be if you do 25 times the square root of 45. And that would come out to like 167.7. It says round to the nearest mile, so that would be about 168 miles. And number 2, they want us to find the perimeter of this triangle to the nearest tenth. They are going by ones. So if you count the squares for these, just need to find the hypotenuse here. Since this is the only number that doesn't come out evenly, we could round this to the nearest tenth. And then finding the perimeter, we need to add our 3 sides together. So we'll add that to our other 2 sides. That was the hypotenuse, so it should be bigger than either of the other 2 sides, which it is. I'm sorry. That wasn't our answer there. It should be 9.2. And then when you add those together, you get 22.2. Just looking at the wrong thing. And then number 3, we have an equilateral triangle. What are the coordinates of point L? So we could make this into a right triangle. If we just look at one of these parts, this is 3. And if you count the squares, no, never mind. We don't know what point L is. The thing about this problem, it's a little bit tricky, but it says it's an equilateral triangle. So that means all 3 sides are the same length. So this bottom side has a length of 6, and the other sides actually have lengths of 6 also. So that's how we know this side from L to K has a distance of 6. And then what we're trying to do is find this distance of this leg of the triangle. So 6 would be our hypotenuse. So that would be square root of 27. Square root of 27 is about 5.2. So this point here, I put a point, a red dot here, is at the point 6, 2. And what this means is from that point we need to go up about 5.2 points, 5.2 units. So 5.2 plus 2, adding that to our y value, would be 7.2. So this would be 6, 7.2. And that would be our final answer. So this gives you an idea of how to find answers to problems involving Pythagorean theorem. Have a good day.